All right, everyone. We are going to be presenting a workshop here. This is kind of just a case study of iterating on a design. We sort of took a bunch of pictures and videos of our 2023 and 2024 intakes as they developed through the season. And we're going to talk through how they started, what changes we made, what tests we did, and what worked and what didn't. I think we're going to have a little Q&A session after 2023 and then a separate Q&A session after 2024. So if you have any questions, feel free to hold them until the midway point. And yeah, hope you enjoy. So quick introductions.
Okay, so hi, my name is Emma. I was on the 2023 to 2025 grad team. I designed the 2024 intake, and I'm currently the designer.
My name's Matt. I'm a mechanical engineer. I work at a company called Advanced Farm. We make autonomous fruit harvesting robots. And in my free time, I am a coach at Citrus Circuits. This will be my 10th year coaching in MRC. I work with the mechanical strategy teams. So, quick outline. Both of these are going to look very similar. We're going to talk about some early concepts we looked at. In both cases, we had a big design pivot partway through, and then we're going to look at how that design kind of iterated out until the thing that we ended up competing with. So starting with 2023. So in 23, I guess I probably should have put a little game intro here. The 2023 game, you were picking up little traffic cones about yay high and some inflatable cubes. They were really more kind of ball-shaped, but about this big. You were allowed to hold one at a time. And you really wanted to have an intake that could do both, ideally, just for simplicity. So our original concept was, please load. There we go. We called it the pinball flipper. I think this one we're still calling it a crossbow, but eventually became a pinball flipper. So it was kind of just a bunch of vertical wheels that you could push into a cone and it would center them. Worked pretty well. This is very much our prototyping style. Laser cut pieces with drills and half-inch sockets driving hex shafts. This is basically how we start every season. So the cone worked pretty well, the cube not so much. The cube just kind of bounced around. Nothing too inspiring about this. So in order to grip a little better, we added this sort of flip-out actuation thing, so that way this is spring-loaded back. And when the cone comes in, or the cube comes in, these little flippers would flip out forward to help pull stuff in, and to help direct guide the cone in, we decided to put this little over bumper intake that would push the cone down to help pull it in. And this one was definitely working, way more promising. We were, at this point of the season, talking about only picking up on the shelf, which means we would always be picking up against a backboard, except for auto, where we just be controlled enough to hit it in the center. And it was like pretty much doing the do, right? It wasn't perfect, but it did the job. I think there's a cube video in here. There we go. So there we go. Picked up both, did the little pinball thing. But then what happened after that is Robonauts, every year they publish the Everybot, and they published their Everybot in 2023, and we looked at that and we're like, oh wow, that is so much smarter than all of this wild stuff we were doing. So we're just going to do this instead. So we saw this intake, the robot itself, really tall, we weren't sure we loved that, but the intake, fantastic. So after a couple weeks of build season, we dropped our original design and started over with some more laser cut prototypes. These are, again, laser cut 1/4-inch Baltic birch with some bearings pressed on the side, hex shaft through them, and we were, at this point, it looks like we were actually using motors to drive stuff. So we have just an old robot control system off to the side that we were using to just spin motors. So we did the wood prototypes. Most of this was about figuring out what kind of rollers worked, how big they needed to be, which parts needed to be squishy. And we did some tests and we're like, yeah, this is working, right? This looks way better. It's authoritative. You can just ram the card into it. This, by the way, is just it's a moving dolly that we had everything kind of bolted to. You can see that in order to hold it up at the right angle, we just have some white gaff tape kind of pulling it back a little bit. It's held on with clamps. This is, again, very Citrus circuits. This is basically how we do every bit of prototyping. So once we had that, then we started working on, let's look at something that looks like a design. So this back here was January 21st and 22nd. So the robot was already starting to take shape, assuming we were going to use that pinball flipper intake. So we'd already built a bunch of stuff, but luckily we were able to just throw this intake on there instead. So here it was. This was the first iteration of this intake. You can see that we knew this was very prototypey because we didn't even bother cutting the shafts in it. We just had them sticking out like a foot either side. It was very scary to drive, but it did let us at least run into game pieces, pick them up, put them up on the grid. For those who don't know, the scoring area in 23 was called the grid. So you can see here this was a bunch of polycarb pieces on the sides. We had these aluminum shafts through the middle to help provide some rigidity. It's very floppy. And then just green squish wheels throughout the whole thing to pick stuff up. This was, by the way, incredibly heavy. This was like a 17-pound intake or something, because squish wheels are not lightweight. So some stuff we learned here while playing with this is that the roller height off the ground was really, really critical. So we wanted the cone to basically hit right here on this edge in this little space, and then it would get sort of sucked in here and pulled up here. But the problem is we had this intake on a big wrist. So when the robot drove it, the motor was sort of trying to hold it in place, and it would be flopping around. And it really just couldn't hold its position very well. So we couldn't really keep the intake in that spot that it needed to be in. Sorry. So as a quick fix for that, we tried putting these little Omni wheels on the ground. So that way you can see that, if you look closely, this is just a piece that we bolted on outside the intake, just a second piece of plastic. Omni wheels sticking on the bottom of that, but that way you can run the intake into the ground. And the height of all that is just set by the floor. So that way we didn't need to worry about how good the wrist was and all that stuff. So this was our solution here. It worked pretty well. Here it is doing some scoring. Again, you can see we have these like full-length shafts. We didn't feel like cutting them because these were like raw stock from WCP and they're like $30 a piece or whatever. So we left them full length in case we needed to change stuff, which we knew we would. So it worked. Actually, this video should have been on the previous slide. It doesn't have the ground rollers. But you can see kind of as it moves, it shimmies around a lot. So the ground rollers helped with that. The other thing that was added here is this bar underneath, which is called the kicker roller. So it helps lift the game piece up off the ground to make sure you're kind of controlling it a little better. That's kind of a pretty common intake element that's useful a lot of the time. Okay, so this is the end of January. A few weeks later, this robot's starting to take a little shape. We had to make some changes. Elsewhere on the robot, this originally was significantly longer, and we shortened it a bunch because we now had this wrist. But so it took a little while to get here because we had to change a bunch of stuff on the robot. But once we're starting to get towards like a little more of like, this could work. This could be real robot stuff. So changes that are made here. We had these big squish wheels, kept them there because we liked that compliance, we liked that squishiness. It gave us a really big surface that the cone could hit. But these top ones, we replaced with just one big dead axle roller. These are the same, we got this roller design from 254, we used it on the 2022 robot, and we've used it on 23 and Spoiler's 24 robots. A bunch of teams have done this. We didn't invent it, but we sure do like it. So other changes. So that last rev intake had those like little spindly aluminum guys going across for rigidity, and we said that's not nearly enough. So we decided to get all fancy, and we tried these carbon fiber tubes to tie the two sides together. And because we didn't want to drill carbon fiber, these are 3D printed like clamps. If you see right here, you can kind of tell there's like a clamp hole there. I think we call these plates ducts because they kind of had a little duck bill. So it clamps on to the tube there. That way we didn't have to do any drilling into the tube, which weakens the tube a lot. You were like, yeah, we're good at robots. We're so good at robots. Look at our carbon fiber. But unfortunately, this had a ton of problems. Just nothing but problems, really. So one of the big issues with this, I tried looking a ton for pictures, but because we were just clamping on the tubes, there was nothing keeping stuff from twisting on them. And you could actually take one side of the intake and twist it like this, and then let go, and the plates would hold in this like skewed position. So basically, we'd be playing just fine. The driver would make one mistake and like clip the charge station, or intake a cone from the side instead of the middle, and suddenly the intake does this, and we're dead in the water. So that was a big issue with this, and we were struggling with it for a while. The only change we made here was making these two pieces one giant piece. I don't remember why we did that. Wish I did. For weight savings, because all those big chunky wheels are super heavy, and we really wanted this thing to be lightweight since we were flipping it around and putting it out in this elevator. You replace those all those giant 4-inch wheels with two 2-inch diameter rollers. One thing that this gives us, is there a good video of this? I don't think so. It sort of gave us a big flat surface that the cone could hit. So the cone's here, and it sort of smacks into both those rollers at once. It gets pulled up. One issue with only one roller is that we would tend to knock cones over. So you get two of them, and it would sort of hit and drive up and in.
Oh, I also just wanted to add, I'm not exactly sure if it was this point, but as we ran more and more driver practice, we realized that, again, like the wrist was super wobbly, so every single time we had to drive up to the human player loading station, we had to time how far we could go forward so that the bounce of the wrist could actually go over and then intake the cone. And through driver practice, we also found out that originally we had a belt running, I believe, I don't remember if it was this version, but all of these versions kind of happened so similarly that we decided to swap out a belt for chain. It actually helped out a lot, even though it was just kind of like a quick moment decision. It stayed on the final robot. So
For the wrist twisting, yeah, you can see, so this right here, this was the wrist twist. Oh, the other thing we were still doing at the time, so if you look at this screenshot, you can see that there's two Falcons back here. These were the wrist and the rollers. So it was like, this one was the wrist and this one was the rollers. But the problem is that we had to put all that roller power down through a belt here, and then up through a belt here to this pulley on the middle of this. And that shaft would just, like, every time you turn it on, it would bend back under the torque, and the teeth would skip. And it just did a terrible job of transferring torque back here. We did this to try to keep the weight of the motor as low on the robot as possible, and to keep us from having to swing around as much weight as possible. But this was, it was giving us problems literally all season.
yeah, we continue just to work on like different ways we could probably transfer the powers. You can probably see in the next few slides we tried like flat belts.
And we actually have a flat belt.
Yeah,
I don't know if I had an earlier one.
No,
No, we haven't
I
got a
think
flat
it's
belt. Okay, stop it.
yeah.
All right, so because we're running into all these issues, we actually briefly panicked and tried going back to the pinball flipper. We were like, oh, what if we angle it downwards instead of flat? Is it gonna work better? And the answer is no. It still sucks. We were briefly hopeful. We had like a half-hour glimmer of joy that we could go back to it and solve our issues, but it didn't work.
Oh, this is a flat
Yeah, so here you can see we're trying to transfer torque through this belt up to the flat belt. And it just like isn't able to transfer enough torque through this flat belt to all these things. And we're like, okay, well, this isn't working. This isn't good. This is just a test video of some stuff working. I think everything works for, oh, right, this is the weak wrist. I forgot about that. due to some packaging constraints, we couldn't fit enough of a reduction into the wrist, so it could like barely move. So like you intake the cube here, and then try to raise the wrist, and it goes, oh god, there we go. And it finally comes back. And that was obviously also unacceptable.
Yeah, I think we also tried, we never actually made the version, we did 3D print the pulleys for it, but we did try to power it down the middle straight with just belts. And that would split the intake rollers up into two, but we never actually executed it.
Did we never do that?
We never did, but on the previous slide there was the image of it.
Okay. Alright, so after we had all those torque transfer issues with the flat belt, we're like, okay, we're spinning too much stuff with this flat belt. If we reduce the amount of torque that the flat belt has to spin, then maybe it'll work. So we got rid of our second roller on the cone, even though we knew we needed it. And we tried doing it with just the one roller, and we're like, oh, okay. Or I can get there. Give you all the
Yeah.
videos. There we go.
Okay, so for January 11th, 2024, we actually didn't really prioritize prototyping as much in the very beginning, just because we wanted to get something out so software can work under autos. So we kind of just sketched something that looked right, and this is what we came up with.
This was the alpha robot that we posted up like so this is what that looked. This was like its first time moving all of its parts.
Yeah.
Blazing fast.
Yeah, and we actually stole the 2023 parts off of it, so all the rollers, even on the intake and the feeder rollers, were all from the robot that we did last year.
Yeah, those were all off the 2023 practice spot.
Yeah. So it would turn out to be kind of a mistake that we didn't really prototype that early. Oh. Yeah, so without any really prototyping, we kind of just jumped directly into our over-the-bumper intake design. At this point, we didn't think about going over-the-bumper yet.
I mean, that idea hadn't really kind of taken off yet,
Yeah.
generally.
So we decided to just kind of improve upon Alpha's intake. So it's because immediately after we pivoted to under the bumper, once there became more and more cheap Delphi posts about it, we were like, okay, why not try this out? Like, a lot of teams are having success on this, why not give it a shot? So again, we didn't do any prototyping, and we just took everything off of Open Alliance, Cheap Delphi, and it was a huge mistake. Yeah, and it was pretty bad because we stayed up really late to work on this, and it ended up not working, so always prototype. So this is kind of what it looked like. We have the CAD for it. Basically, it was broken up into two parts. We had an indexer and an overbumper intake. You can see that it looks pretty good, but in reality it wasn't. This indexer blocked half of the PDH, so the members had to bend the indexer to access anything. So you can't really see here, but we also had two flat bolts running in front, on the very front of the, oh, right here. Yeah, two flat bolts trying to guide nodes in as the intake would intake the nodes. So here's a video of why we should prototype in the future.
So for what it's worth, I think this is literally the only video that exists of this intake. We all hated it so much, we didn't even, like, we're too disgusted to record anything. So it couldn't do anything. Couldn't do the job, couldn't intake a note, and we would have learned that if we had prototyped literally anything. But instead we were like, yeah, notes seem really easy. We'll just pick them up, it's fine.
Yeah, we never ran like any driver practice with it. We tried to intake that one note, and we just didn't do that ever again.
Yeah. So outside of the intake, we had this whole thing where we have an alpha robot, and then a beta robot, and then hopefully a comp robot, which is just like slightly improved beta. This beta robot we started working on I think the 17th, and we literally threw it in the trash can on the 31st. So fully threw it away, dead and gone within about a week of this. No, I think that's the next one.
Yeah, so our next plan was to come up with a beefier intake with full-on 5/16 aluminum side plates to survive a lot of the under-the-bumper intakes. We nicknamed it Old Ironsides because it was supposed to be like a tank. So at this point we didn't really think about maybe that it would bend and we couldn't bend it back. So we just directly sent the idea, and it still has everything else to it. It still has the dead axle rollers that we put on our first design. And I don't remember what this was.
Yep, so this is a video of it working.
Sorry.
No, that's just yours.
Oh, I don't have anything to say.
Oh, it worked.
Okay, yeah.
Intake did the job.
It looked like really good, and we were pretty happy with the results. I think this is the part where I say until this happened. So we were starting to run some more practice matches with it. We were getting some driver practice on it, and obviously we come across some failures. The first thing was the front roller was exposed. It would take all the impacts. Every time we ran into a wall, we ran against something, that pulley and that whole roller would be the first thing to take impact. So you see, you probably can't, not in this example, but the 3D printed parts were pretty damaged, and the belts would skip right up onto the rollers, everything. And to your left, all of the 3D printed rollers just sheared. It was like a massacre of the 3D printed parts.
I would like to say that the intake did actually still work like this. Like with all the rollers flopping around, it could actually somehow still intake it up.
Yeah.
It was just, obviously we didn't want it to do that, but like, it was pretty cool.
Yeah, so we decided to change the profile of the plate. So now this time, similar to actually 2023, that the plate would be the first thing to contact and not the actual rollers, just to maybe, help protect them a little bit. So all of these were figured out through, hours and hours of driver practice. As we realized more and more breaks, we came up with designs to solve that problem.
So one of the ideas we were playing around with here is we're like, where's some benefit we can draw from being an over bumper intake in a game full of under bumper intakes? Is anyone in this room watch BattleBots? All right, so everyone in BattleBots always talks about controlling the ground game. We realized that if you have some wedges on the intake, we could probably reach under bumper intakes, and like on center line auto engagements might be able to actually pull a note out from another robot, because we could get under them and lift them up off the ground and grab the note. That was the idea. It worked once in one practice match. It was very cool.
Yeah. And we thought this idea would be pretty cool, so we stuck with it, and you can see that we actually, started pocketing the inside plates to save some weight. Yeah, so after we did take quite a few hits, so, oops, wait, let me go back. That's a spoiler. So we took quite a few hits, and the front roller would, again, just completely shred itself. It would dent, it would bend everything. So we moved past the original 3D printed rollers that we came up with, and we put a massive axle through both the front two rollers, so the top and the bottom roller. And we made these upgrades on Epsilon, which had the previous intake without the sharp kind of wedges and the new intake. So it was super easy to swap out, so we just made those changes on both of them, and it held up a lot better.
Until.
What?
Until.
This image. So this happened at, I believe, SBR. Yeah, and I look super happy.
Like very smiling through the pain.
Yeah.
So one thing to note on this, so both of these rollers have a 1-inch diameter aluminum tube in them. So with that plastic roller on the outside is bent in, it's also bending the aluminum in on the inside. A problem here is that because of that aluminum tube inside, like if the aluminum tube wasn't there, the plastic roller would probably still like spin and just waxed up around. It might still be able to work in a pinch in a match, but with the tube in there, the roller was just sort of bound up against it and no longer spun.
I think we still have that too. We never threw it away.
As a trophy.
Yeah. And so on SBR Sunday, we kind of realized that there was another problem, that the whole intake would skew a certain direction. So after every single match, we had to get like Devin, one of our strongest mentors out there, and brace the robot cart, and he would like just grab the edge of the intake and bend it back, and we had to do this after every single match. So we realized that maybe aluminum side plates weren't that great.
we're basically relearning lessons that we've learned over and over and over again. Like, how many times have I told a kid that an intake should bend and not break? And like sometimes you got to teach yourself a lesson over and over and over again for it to stick.
Yeah, so on March 8th, 2024, we switched from the aluminum to now polycarb with a little shield of aluminum on the outside, 1/16. And one issue that we still had, we were pretty comfortable with the amount of flexibility it had, but the aluminum plates would still buckle when we hit a testicle. The PC polycarb would bend back, but the aluminum would still stay bent. So as you can see, we kind of drew up little marks over there on the plates of aluminum to kind of reduce that bending. And there we have it. You have the current intake plate. And one other problem that came up was that these wrist plates, they began to wear and tear over time. They actually, you can see some rips on that intake plate right there. So we, although it's small, we still fixed it, and we just increased the material here, and it fixed the problem.
Until, this was actually 2 weeks ago. So postseason, everything's fine, it's not a big deal, but we ran it into, I think we just ran it straight into the truss and just snapped that 70-75 aluminum wrist plate clean in half in a really weird way, like through the rib, like this clean break under the rib, very strange failure.
Any questions?
Any questions on the 24 intake? None? And you got, what's up?
You erased a prototype for impact resistance?
You run it into a wall.
Yeah. And
So-
did it break when you did that?
We didn't do it with this intake because we knew that there was no shot it was going to make it. This past year we were running with a 4-year experienced driver, very, very good, and we were like, just try not to hit stuff, you know. Saw you first.
What about the under the bumper intake didn't work again?
What about it? Literally all of it.
It's like,
So it couldn't intake a note.
why didn't you add like more friction on the rollers? Because I saw like the note kind of.
So it was
sinking.
already covered in cat tongue tape, which is about as grippy a material as you can put on an intake. So like more friction was pretty hard to do. There is a better question of why didn't we just try iterating a better under bumper intake? So that kind of came into bigger issues with beta, which is that the beta robot, the problem wasn't just the intake. The whole robot was bad. Like, the whole robot was as effective as this intake. Every single part of it was completely underthought, and we put literally no prototyping time into it, and we knew we needed to scrap the robot, not just the intake. And we were looking at, like, what do we know that we can do? And we're like, we know how to make an overbumper intake. We did it on alpha, it works great. So we're just gonna do that because it's not a risk. It's not a functionality risk.
So you said the over the bumper intake was better than the under the bumper because you said one of the things was it could steal from the other robot. Was there any other like moments kind of like that you found over the bumper was better?
When you're playing forward field cleanup and there's a note stuck in like a corner, it was really nice being able to have an intake that can kind of reach into a corner. A lot of under bumper intakes, the whole robot would have to try to fit into the corner and you couldn't get the center intake part to hit the note. So that was a benefit. That benefit didn't really come out until Champs when the whole passing meta became a thing. But that was there.
When do you guys decide a design is bad enough to pivot on it?
There's just so much gut feel involved in that. So with this one, I think we actually called the decision to change, to start designing the new robot on like the 22nd. So this robot was still coming together. When we were just looking at it and we're like, I don't see it working. It was me, Mike, and Brendan, our design lead from 24. Just like, do you see a world in which we fix this robot and make it do what we need to? And we're all just like, I
It's
don't.
also just when you spend so much time on it, yeah, it just doesn't work.
Yeah, and it's a matter of how much time we had left. So I think made that pivot on the 22nd, like I said, and if it had been the 26th, probably would have been out of time, and you would have seen a really, really, really terrible citrus run. And we would have just sort of struggled through it.